Hello, this is John from TC Math Academy. And in this particular video, we're going to focus on graphing rational functions. And here's the problem that we're going to be graphing. We have f of x is equal to 2 over x plus 5. Now, I did say that this is a rational function. Now, just as a general rule, anytime you hear or see this word rational in mathematics, especially like in algebra, you want to kind of think about fractions. Now, of course, there's a little bit more of a precise definition to rational functions, rational expressions, rational equations, rational numbers, and so forth, right? But again, just as a general rule of thumb, when you hear that word rational, think about fractions. And of course, that's what we have right here. We have a function has a numerator and a denominator, and we want to graph this thing. Now, as my little tagline says, this is not so simple. Okay, it's not impossible or overly difficult, but it does require a few main steps to be thinking about. Now, I don't want to give anything away because I want to give you a full opportunity to come up with a sketch of this rational function. And if you know how to do this, go to take out a piece of paper. It'll probably take you a minute or two, and maybe like a couple minutes to actually come up with a pretty decent sketch. Not a perfect graph, just a decent sketch. And if you know how to do this as well, make sure you label on your sketch, on your graph, kind of the important features of this graph. All right, so if you want to go ahead and try that, go ahead and pause the video, work on that. I'm going to show you the correct sketch in case you kind of judge, in fact, whether you know how to graph rational functions. And then I'm going to walk you through step by step on how to graph rational functions. Right now, this is a pretty big topic, so this won't include everything. We're really kind of talking about much more advanced problems, but certainly if you're at the Algebra 1 or Algebra 2 level, you're going to get a good quick review on how to graph rational functions. Also, if you need math help with the course you're taking, test prep or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go take a look at a sketch of this. Now, your sketch may look a little bit different, but this is basically what I'm looking for. So you have, I kind of have my little y-axis got erased here. So you want to just have a nice x-y axis, and here you want to identify the graph. Now the graph is in green. Okay, you have what we call branches. So this is not connected, right? So this is one part of the graph, and this is the other part of the graph. And these parts right here, x is equal to -5, this little dotted line, is what we call a vertical asymptote. Okay, so you want to identify that on your graph, and y equals 0 is what we call a horizontal asymptote with respect to this particular problem. So that's actually the x-axis. Okay, so you would want to label this and, of course, show these two branches and show the kind of general behavior of the graph, right? Anytime in mathematics, your teacher is going to give you a pretty good amount of latitude in terms of your graphs, as long as your scale that you're using is reasonable, right? And you're kind of showing the main characteristics or behavior of the graph, you should be able to get like full credit. So don't feel they have to have like the perfect scale graphing paper for all, every single thing that you graph in mathematics. You need to get good at kind of freehand sketches. But again, be as neat as possible and make sure you show that behavior. Okay, so if you have something like this, well, that indicates to me that you definitely know how to graph a basic rational functions. And let's celebrate by giving you a nice little happy face, an A plus, a 100%, and multiple stars. So you can tell your friends and family that indeed you know how to find vertical and horizontal asymptotes and actually construct the graph of a rational function. Now, what level of math are we talking about here? Well, this is stuff that you will learn like in Algebra 1, okay? It's certainly like Algebra 2, so if you're beyond these courses and like in college algebra, pre-calculus, this is stuff that you were kind of expected to know, but of course, we all tend to forget things that we don't practice. So let's go ahead and get into this right now. And if you need help with rational functions, rational equations, rational expressions, check out like my Algebra 1 or Algebra 2 course or pre-calculus course, whatever level of math that you're in. Okay, so here is the problem on a level of difficulty. This is a very basic rational function, but you're going to see here that it's not so simple in terms of just coming up with the graph, right? And the graph in and of itself, has a few components, right? We have like a vertical asymptote, a horizontal asymptote, and what we call branches. These two graphs are not connected, so this is one branch, like a branch of a tree, right? So here's a tree. You have one branch and you have another branch, and you can see this behavior here of the graph. See how the graph kind of approaches the x-axis. Now this right in here, let me just show you something because I'm going to show you what's kind of the first step. This graph is not kind of running parallel to the x-axis. In other words, it's not going to be like going, like railroad tracks down this way. What you're kind of indicating is that this graph is going to get closer and closer and closer to the x-axis, but never touch or cross. So this kind of behavior, where you have a graph kind of just coming in closer and closer and closer to a boundary line, like what's going on over here, is called asymptotic behavior, okay? And these boundary lines are called asymptotes. So when we are considering graphing rational functions, the first thing that we need to do is find all the asymptotes. Now, in this particular problem, we're going to be focusing on vertical and horizontal asymptotes. There are what we call sloped asymptotes, or asymptotes with angles with them, or slopes, as you will, but that's a little bit more advanced mathematics. We're not going to be covering that in this particular problem, right? So, but if you're at like the pre-calculus level, you can check out my courses on that, or my pre-calculus course to help you with that kind of level of stuff. And by the way, too, let me just say one other additional thing. If you're in Algebra 1, you're probably not using a graphing calculator just yet. You might have one, but if you're like in Algebra 2 or college algebra, certainly pre-calculus, you definitely probably are required to have a graphing calculator, something like a TI-84, TI-83. There's other ones out there, but those are probably the most popular. And it's important that you know how to use your graphing calculator, which is, a few other additional steps. So you should, after you do this by hand, you should, if you have access to a graphing calculator, make sure you know how to use that graphing calculator to kind of double check your work. Okay, so anyways, the first step is going to be, we're going to search out and find all asymptotes, right? Sometimes a rational function will have no asymptotes. Sometimes it will have all different types of asymptotes. Just don't know. All right, the second thing that we're going to do is make a table of values, okay, of XY points. Nice little XY table like so. When you first start graphing linear equations, you probably learn how to fill out a basic table like this. And the great thing about a table of values, okay, you can construct this with any function in mathematics, okay? You don't even have to know about asymptotes or anything else. If you have an accurate enough table, or not only accurate enough, but if you have enough points, basically you could just kind of connect the dots and you can kind of graph any function. So when in doubt, let's suppose you forgot, everything about asymptotes and whatnot. You're like, I have no idea what to do. Listen, make yourself a table of value, and you can, if you have enough points, you should be able to see the general behavior, right? So this is a really good tip for, functions beyond just rational functions. And then last but not least, what we're going to do, once we have this table, once we have our asymptotes, kind of our boundaries, we're going to go ahead and sketch the branches of these rational functions. And rational functions are characteristic, characteristic of having branches. In other words, you're not going to have things that are kind of continuous, like a polynomial function. So like a polynomial, you'll have something like that, or like a quadratic equation. You have something like this. It's nice and continuous. But a rational function, you're generally going to have branches. Okay, you can have all sorts of branches, things like this, like that. But that's what these little parts of the graph are branches, and they're separated, of course, by asymptotes. All right, so let's go ahead and get into this, and we'll kick this off by discussing asymptotes. Now, I kind of showed you what an asymptote is, and again, we're going to focus on vertical and horizontal asymptotes. Again, there are sloped asymptotes, but that's a little bit more advanced mathematics. But let's go ahead and get into this right now. Okay, so here is a general rational function. So a rational function is kind of defined. It's a function where you have a numerator and denominator as functions, and those functions in and of themselves are polynomials. But basically what you need to know is the following, okay? So in your kind of function that has a fraction, what you're going to do for the vertical asymptotes, to find vertical asymptotes, and these are boundaries that are this way, right? A vertical line boundary, is you're going to take the denominator, okay, and you're going to find the zeros and roots of that denominator. So what does that mean? Well, in practical terms, all that means is to take the denominator function, okay, so in this case it's x plus 5, and we want to solve for x. Okay, that's finding the roots or zeros, or just solving for x. So that's pretty easy. So we're going to take x plus 5, set it equal to 0. Okay, that's how we're going to solve for x. Let me just make sure that I'm being clear. What you're going to do is take that denominator function, set it equal to 0, and then solve for x, right? That's finding the roots or zeros. And here we have x plus 5 is equal to 0. To solve that for x, very simple. Simply subtract 5 from both sides of the equation, and we get x is equal to -5. This is our one and only vertical asymptote, okay? Now, if, for example, you had like x squared plus 4, right, was in the denominator, of course, it's just x plus 5. We would set this, well, let's make something a little bit easier. X squared minus 4. Let's say this was in our denominator. We set this equal to 0. We're going to have x squared is equal to 4, and x is going to be equal to positive and -2. So in this case, you would have two separate vertical asymptotes, right? So there's not just one vertical asymptote. You just don't know until you do the work, right? But in this case, we have one and only one vertical asymptote. That's going to be the line x is equal to -5. Okay, so that's vertical asymptotes. Now let's go ahead and get into horizontal asymptotes. And horizontal asymptotes are a little bit more involved in terms of how to find them. So here again, we have our function. And to find the horizontal asymptote, basically there's three cases. And what we're going to have to do is compare the powers or the degrees of both the functions in the whatever respective functions in the numerator. We're going to compare it to the denominator. Okay, we're looking for the highest power or the degree, and that's going to tell us how to what type of horizontal asymptotes we have. And it's just easier to understand what I'm saying by looking at an example. So let's go and take a look at three examples here. Again, we're finding horizontal asymptotes. We're looking for horizontal asymptotes. That's going to be boundaries that run, lines that run horizontal, right? So in other words, our branches of our rational function would approach this horizontal, whereas a vertical asymptote, it's running this way, and your branch is kind of approaching it like so, right? Okay, so let's go ahead and take a look at the three cases for horizontal asymptotes. Now, what you're focusing in here on is the degree. Okay, so here, our first example, you can see that we have a third degree polynomial in the numerator and a second degree polynomial in the denominator. But it doesn't make a difference if the degree of the numerator, okay, the function of the numerator, in other words, if the numerator is a higher power than the denominator, that function will have no horizontal asymptotes. Okay, so in this particular example right here, there are none. Okay, there is no horizontal asymptotes. So again, if the degree is higher in the numerator than the denominator, there are no horizontal asymptotes. Okay, so let's take a look at another example. What happens if the degree in the denominator is bigger than the degree in the numerator? So something like this, 5x over x squared minus 4. So here, the denominator function has a larger degree than the numerator. Well, in that case, your horizontal asymptote is y equals 0, and a y equals 0 line is what? It's also the x-axis, okay? All right, and lastly, if you have a situation where the degrees are the same, like in this case right here, we have x squared and x squared, that's the highest degree in the numerator and denominator, then the horizontal asymptote is going to be the ratio of the leading coefficients. In other words, we're going to construct the line y equals, and then we're just going to use the leading coefficients 8 and 16, and this will be the line, or horizontal line. Of course, we would simplify this down to the line y equals 1/2, but that right there is the three cases, all right? So you got 1, 2, 3 cases. So what's our situation? Let's go back up to our problem. So if you see 2 over x plus 5, we're looking for the power, right? Who has the highest power, or are these equal power? Well, you can see that we have an x down here, or x to the first. Now you're like, well, I don't see any x up here. Well, really, there's x to the 0 power. Okay, you're like, what do you mean by that? Well, x to the 0, anything to the 0 power is what? 1. Okay, so this is really just a fancy 1. It doesn't exist. We wouldn't write it there, but just so you kind of understand that if you want to compare degrees, it should be clear that the higher degree is in the denominator. Okay, so where does that leave us in terms of what case here? It's this case right here. So y equals 0, or the x-axis, is a horizontal asymptote. Okay, so what does that mean? Well, let's go ahead and just put this all together. So we have y equals 0 as a horizontal asymptote, and we already figured out that x is equal to -5 is a vertical asymptote. Remember, we went ahead, let me just show you right here. We went ahead and set our denominator function equal to 0 and solved for x. So we got x is equal to -5. So let's go ahead and just plot out a basic x, y chart here. And the x-axis is also acting as a horizontal asymptote. Y equal to 0. And then x is equal to -5 is a vertical line that goes to -5 on the x-axis. So at this point, you're saying to yourself, okay, these are the boundary lines. We're not going to have this graph cross through like this. It's not going to cross through this way because these are boundary lines. But what you don't know is, does the graph behave this way? There's going to be some branches, right? Does it behave like this, or maybe it goes like so? We just don't know that, okay? We don't know this yet, okay? So the way to figure this out is we're going to move on to step 3, and step 3 is to, or step 2, excuse me, step 2 is to construct a table. Make a good old-fashioned XY table. And this is, basically going to be up to you on how many points you want to construct. You're going to need to know enough points here to plug into this function to kind of see the behavior. All right, so let me kind of show you. Of course, you can see my points here, but you don't have to use my points. But what you need to do is the following, right? You have to say, let me test some points over here, okay, to the left of x is equal to -5. So I'll test some x points, select some random points over here and some random points over here. And sometimes it's good to select a kind of a larger x, positive x or negative x point, just to kind of make clear what's kind of going on in these kind of what we call end behavior, or get really close to an asymptote too. Okay, that's a really kind of good way to do this. But you don't need to have a ton of these x points, just enough to kind of get a sense of what's going on. Like, wait, how is this graph kind of, how are these branches being constructed? So I'm going to select a few over here and a few over here. Again, I'm just kind of showing a quick example of how to do this problem. So here are my x values, right? So I just kind of made these up. So x is -10, -6. Well, in other words, we're going to construct or find the y value for x is equal to -10, -6, -2, 0, 2, and then 20. Okay, now I selected 20 because I just wanted to show you that, selecting kind of an extreme point way out there on the x-axis it's also kind of a, just kind of confirms the behavior that you're seeing. All right, so getting really far away from an asymptote or really, really close to an asymptote is an easy kind of, it's a great way to kind of verify what you think you're seeing. All right, so let's just kind of, make sure you understand how to construct a table of value. So here we have -10, right? So I'm going to say, okay, where's this point at when x is equal to -10? So you just plug in -10 into the function. And so you can see this is going to be 2 over -10 plus 5, which of course is going to be -2/5. But go ahead and go into your calculator. It kind of helps you out. That's going to be -0.4. Okay, so way over here. So you can plot that point. Actually, just kind of take it a step further. -10 and -0.4. This is the point. This point here, negative. Let me just kind of be a little bit more clear about this. So negative 10, that's our xy point, right? We're talking about xy order pair. So x is negative 10 and y is negative 0.4. This point is on this rational function. Okay, so we're going to be kind of playing connect the dots, but we need more dots to kind of really see what's going on. So you just kind of follow through and just do the kind of respective work here for these points. Use your calculator, by the way. You can work with fractions if you are not able to use a calculator. That's perfectly fine, but get enough points so you can plot those points. Okay, so now that you have your table, what you're going to do is you're going to go ahead and actually sketch the branches out. Okay, so like way over here when x was 20, right? I think I had that on my table. So when x is 20, y is 0.08. So way out there on the positive x-axis, 20, y is 0.08. It's very, very small, right? So this indicates that this branch is kind of getting really, really close to the x-axis. Now, if I kind of go this way and I get closer to this asymptote, all right, so I had a point there, like -2 on the right-hand side, my y is positive 0.6, okay, which is, of course, bigger than 0.8. So right here, -2, it's going up. So in other words, but that might not be enough points for you to kind of clearly see that. So you would want to select a few more points to kind of see, oh, this is going to really make a turn and kind of go up this way. All right. Now, again, it's not going to go past -5, this right-hand branch, right? Because we got this asymptote stopping us. That's why we want to see, hey, what's going on over here on the negative side. So when we to the left of that asymptote, so like -6, we have -2, right? So -6, let's kind of go down here. So this would be like -6 right here. It goes down -2, so that's kind of like down right there, okay? So you kind of see, oh, this is a point, and and generally too, there's going to be some symmetry with these branches, not all the time, but just as a kind of general characteristic. But we can kind of go out to hit -10, right? So that's going to be -0.4. So you're like, okay, let me go over here. So -6, it's -2, but -10, it was -0.4, which is smaller. So you can kind of get the idea, and you can always plot more points just to kind of get more confidence about your graph. Okay, so this is a basic example of sketching the graph of a rational function. And hopefully, you kind of like my little tagline now, not so simple, right? Not impossible, but definitely not trivial, right? It's not just like 1, 2, 3. There's a lot of other type of functions in algebra and mathematics that are a lot easier to graph than rational functions. But like anything in math, the way you get better at this is to practice, right? To have a good set of notes, to have great instruction, have everything lined up as you take it just one problem at a time. Okay, so again, if you need help with this, check out like my Algebra 2, College Algebra, or Pre-Calculus course. Really get heavy duty into rational functions. Extremely important that you understand this. This also is kind of touched upon in Algebra 1 as well. It all depends on what Algebra 1 course or first year algebra course you're taking. But believe me when I tell you, a lot of students do get confused with graphing rational functions. And hopefully this little video helped you out. If that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.